welcome back to my channel. Thank you for always choosing to learn through us. And if you are new to this channel, I say a very big thank you for learning with us today. Now, in our today's class, we are giving this question to answer. Remember, we are still on limits and continuity of a function. And in our previous tutorials, we talked about what limit is and different ways to evaluate limits. Now, in today's class, we are giving this question. Now, you'll be like, relax, okay? They are simple to answer. It's a home. Here is a home where math is made simple. Now, let's go through this. When you say this kind of function, what do we call this function? This is called a piecewise function, okay? It is piecewise because you look at this is a function at this interval, this is a function at this interval. Now, they are now different functions at different intervals answering one particular name. So when you have a piecewise function like this, it simply means a function that is built from different functions at different intervals. Okay, so this is piecewise function. Now the question is this particular function continuous? Because sometimes piecewise functions are continuous, sometimes they are not. But it is our duty to identify if this one is continuous. And remember, if you are new to this channel, please don't forget to subscribe to us, like us, and also leave your thoughts with us in the comment section. Let's know how you feel about what you are about to do today. Now, if you're ready for today's class, let's work it out on the board. Okay, for a function to be continuous, three things. One, such a function must be defined. If I'm giving a function and it is at x equal to -2, like we have it here, then for it to be continuous, f of -2 must be defined. 2, the limit of such function as s approaches -2 must exist. Then 3, f of -2 must be equal to the limit of f of x as x approaches -2. I hope you got that. These three conditions must be satisfied for a function to be what? Continuous. Now let's take them one at a time. This is what we are given, and we are told, does f of -2 exist? Now, when you look at this, remember we said this is a piecewise function having different functions at different intervals, okay? But they are answering one particular name. Now, the question is to be very careful in identifying where we can have x, because when you look at this interval, let's identify this interval. It is just simply, this is, if you draw your number line, this is our origin 0, here is 1, here is 2, here is 3. Here is -1, here is -2, okay? So you see that the x values are within the range of -2 and 3 for this. Now for this, if I represent it on a number line, this is 0. That means x is moving towards the left side, okay? So we have -1, -2, here is -3. But remember that if x is less than -2, it means we are going to begin, x cannot be, just watch how we represent such. This is how we represent such using your number line. You see? Meaning that we are not going to include x at -2, but other numbers. Now the question is, does this particular function exist at x equal to -2? So the question is, where do we plug in which of these functions are we going to use to test for x equal to -2? Let's go to the first one. Where can we have x at -2? This particular function, because here we cannot use x as -2 since x is less than -2. I hope you got that. So what we are going to do here is, this is the function we are going to use to answer this particular question. So we are going to have that as 1. Let's get f of 2. f of -2, we are using this function. We are using this. F of x is equal to x squared minus 3. Okay, because that is where we have x as -2. So we are going to have f of -2 will give us negative 2 squared minus 3. Remember, negative 2 squared means negative 2 multiplies negative 2, which will give us 4. So this will give us 4 minus 3. And 4 minus 3 will give us 1. So f of negative 2 at this point is giving us what? Negative 1 as an answer. So it's giving us 1 as an answer. Okay? Now the next thing is, does this limit exist at x equal to negative 2? Does the limit of this function exist at x equal to negative 2? Remember, limit is said to exist if the left side of the limit and the right side of the limit are the same. Now let's go back to the question. If you are looking at the right side of the limit, let's look at that negative 2. This is our negative 2, okay? Here should be negative 1, here should be negative 3. Now, if you want to look at the right side of the limit, where do we look at? This is the right side, okay? Those numbers that are closer to negative 2 from the right side, that's what we mean. And if you want to represent that, we say negative 2, we use a positive sign on top. It does not mean we are adding, no. This means that we are looking at those values of x that are closer to negative 2 from the right side. And they are negative 2.01, just tiny numbers that are closer to negative 2. I hope you got that. So you are also going to look at it from the left-hand side. And from the left-hand side, we're going to look at those numbers that are also closer to negative 2 from the left. Here we are taking 2 positive, here we are taking 2 negative. So let's look at those numbers that are closer to it. Okay? So in that case, we are going to have, to answer this, let's go back to the diagram. This is our negative 2. And if we are moving from the right, that means we are going to test the value of x at negative 2 in this function when we are considering the right side of the limit. So let's do that now. From the right side of the limit, as we said, we are going to test it here, okay? Because this is where we have it. This is where we have 2 positive, that's from the right. So it means it falls in this particular function. So we are going to have lim of, we are testing the second one, we are answering the second question. Lim of x squared minus 3 as s approaches negative 2 from the right. Okay, so we are going to plug in. Remember, there are so many ways you can evaluate limits, but here we can go with direct substitution, okay, because it can work out here. So we are going to plug in the value of x at negative 2 here. It will now be negative 2 to the power of 2 minus 3. It looks like the one we did here, but they are still not, because there are some questions you cannot use direct substitution for a limit. Okay, so but for this we are using it because you can use it. So this will now give us negative 2 squared will give us 4 minus 3. And if you subtract this, it gives you 1. That is for the right side of the limit. Now for the left side of the limit, we are going to have lim of, which one do we use for the left side? Are we going to use the same limit, the same function for the left side? Remember, the value of x here is between negative 2 and 3. So it means that there's no other value at this particular side. I hope you are getting what I'm saying. There is no other value of x here. It only started from negative 2 and ended at 3. And you know, if you are looking at the left side of the limit, there should be value here, value like 2.01, which is the closest number to negative 2. I hope you are getting what we are saying. Negative 2.01. I hope you are getting it. So, but we don't have such number here. It means we cannot use this particular function to test for the limit from the left-hand side. So, where can we get something like this? If you go to this, remember x cannot be negative 2, which we have said, but there are still other tiny values apart from negative 2, which x value can assume. It means we can have negative 2.01 here. We can have negative 2.001, negative 2 points. I hope you're getting it. So we can find such value in this particular function. So in that case, it means that if we are testing for the left side of the limit, this is the one we are going to use and not this. So we are going to use this to have lim of 2x plus 3 as x approaches negative 2. From the left side, we use this function. I hope that one is clear. So we are going to have, we can also use direct substitution here. So directly plug in your value of x as negative 2. Okay, so we are going to have negative 2. Okay, so we are going to have 2 into negative 2 plus 3. Let's take that again. This is 2x plus 3. Plug in the value of x as negative 2. Please don't mind this. This a negative sign on top of 2 is showing the direction of the limit. Okay, this limit is from the left side, but this one is showing us that it is from the right side. So that is why we have it. So we're using the value of x at negative 2 to have 2 into our x now assumes negative 2 plus 3. If you multiply this, it gives you negative 4, and negative 4 plus 3 will give us negative 1. So you see, for the left side of the limit, we got negative 1. For the right side of the limit, we got 1. Now, can we say that this limit exists? Remember, we also said limits exist if the left and the right side are equal. But in this, the left and the right are not equal. So we can say limit does not exist for this particular function. And if that is the case, we say, does limit of f of x exist at this? We say no, it does not exist. Then the next thing is, we have answered this, and this is the solution. Now the next thing is f of x continuous at x equal to negative 2? It will be continuous if the function is defined. Yes, this one is defined. The function is defined as x equal to negative 2. Second one, if the limit exists. The limit does not exist. Then the third one is if both the function is defined and that particular value is the same with what you have in the limit. But if you look at this, the limit does not exist, but the function is defined. So what can you conclude? Our conclusion here is that this particular function, f of x, is not continuous. I hope that is clear. It's not continuous because the limit does not exist, but the function is what? Defined. So in that case, we conclude that this particular function is not continuous. Now, supposing we want to represent this in a diagram, look at what we have. You know, this is a quadratic, okay? So if you represent the diagram, let's show what it gives us. Let's represent on a plane. Remember, it's between negative 2 and 3. So we have negative 1, negative 2. Here is 0, 1, 2, 3. Okay, so as a minimum, it will start from negative 2 and end at 3. So if you represent that, we are going to have some, we are sketching it, okay? We are sketching. So this is what we are going to have. Now, if you are representing this as a linear, this is a straight line. If you are representing it, we are going to have, it is less than negative 2. So we are going to have, you can have negative 3 here. So if you represent that straight line, you will have something like this. You will notice that the straight line will keep going down, and keep going down. It can't have anything to do with this. There is a break. Okay, and it's because of this break here that we say that the function is not what? Continuous. But remember, there are also some piecewise functions that are continuous. So I will leave that to you as an assignment to fish them out. Remember, if what you did today was very interesting to you, don't forget to give us your thumbs up, share with friends and family, leave your thoughts with us in the comment section. Let's know how you feel about what you have just done, and also support this channel by subscribing. See you in our next class, and bye-bye.